Okay, to find the distance, we're now talking about a coordinate plane. To find the distance between 2 points in a coordinate plane, or the length of the segment, remember these two things mean the same thing, we can use the distance formula. Okay, now this is actually one of two methods I'm going to show you. It's not my preferred because this formula is not on the formula sheet. It's a little tricky to use, but this is what they're asking us to teach you, so I'll teach you this way first. So the distance formula, if you're a fan of this method, if you decide that you do in fact like this formula, remember you're going to have to memorize it. So you're going to find the difference in the x values, and then you're going to square it. And then you'll add that with the square of the difference in the y values. Okay, so what's inside the parentheses, you're finding the difference, and actually it has to do with finding the distance on a number line. Okay, in the x direction you're going to find that length. Okay, and because you squared it, it's going to be positive, and same with the y. Okay, so this is what we would call the algebraic method. So let's look down here at my 2 points. Let's look at this example. It says, find the length of a segment with endpoints at -3, 7, and 1, -2. So they've given you the coordinates of those two endpoints. So I don't really need the graph actually. So what I'm going to do is I'm going to call this point 1. So this will be my x1 and this will be my y1. Okay, and then over here this will be my x2. I'm going to call this point 2 and my y2. Okay, so when I go to plug in, I'm going to take x minus x. So the last thing I'll do is take this square root. So x, it says x2, it really doesn't matter. You can go this way or this way. To follow the formula, I'm going to go this way. 1 minus -3. Remember, it's 1 minus, and this is negative, so I still need another little minus in there. Plus, I can take my y is -2 minus the y from the first point was 7, and I'll square that. Okay, so one of the tricky things about this formula is just what happened here when you subtract a negative. Make sure you've got those both in there because it becomes addition. So 1 plus 3 is 4. So it's going to be 4 squared, forgot my square root, 4 squared plus, and -2 and -7 is -9. Now this is the second place where it gets a little tricky. If you are using your calculators and you leave these parentheses off, it's going to say -81, and that is not correct. So remember that when you square a number, whether it's positive or negative, you should get a positive. So I'm going to get 4 squared is 16 plus -9 squared, that's a negative times a negative, so it becomes positive 81. Okay, so I'm going to add those. I'm going to, I'll move over this way. Okay, 6, 7, this is 97, so the square root of 97. And my directions actually asked me, I said, if necessary, estimate your answer to the nearest hundredth. I know that this is not going to be a whole number because square root of 100 is 10. This is close, so it'll be 9.8-ish. Somewhere in there. Let's use your calculator. So we're going to do, and we can do a lot of this in the calculator, but I did it by hand, but I'm going to do the last square root part here. 97, I said about 9.8, 9.9. Pretty darn close. Okay, if I go to the nearest well, the nearest tenth actually, the 4 would leave it at 8, but my directions said the nearest hundredth. That's the second decimal place, okay? So I'm going to go 2 decimal places. Now I don't just cut that off, so let's review that real quick. If I look at the next digit, it's an 8, so that means I'm going to round up to 85 hundredths, so 9.85. So my distance is 9.85. That's the distance between the two endpoints. That's my length of my segment. Okay, So now what we're going to do is I'm going to show you a second method to do this. The second method is actually my favorite method because what we're going to do is we're going to create a triangle. Now to do this method you have to have a graph. So when I have a problem where I'm just given two coordinates and I do not have it graphed, I usually get out graph paper and this is the method I'll use. So I'm going to create a right triangle, almost like I'm finding slope. I'm going to go up and over, if you remember slope from algebra. Okay, so when I do that, use my horizontal and, oops, that's the vertical, use my horizontal and vertical lines to create a triangle. What I'm doing is creating a right triangle. And although I cannot count these because my units of measure are right here, I can count these horizontal and vertical lines that I just made. So this is 1, 2, 3, 4, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9. And you might notice for 9, those were the numbers that I got right in here before I squared them. Okay? So what I'm doing, and I'm actually jumping ahead, right triangles is in a later unit, but I'm going to go ahead and introduce the Pythagorean theorem to you right now. If you look on, this is my geometry formula sheet for the new SOL. There's two sides. On the back side you have a picture of a right triangle, and they've got this formula here. So this is one reason why it's my preferred method, is because it's actually on the formula sheet. So I'm going to copy down my formula, a squared plus b squared equals c squared. Okay? I just got that right from my formula sheet. Now a and b, those are the two legs, okay? C is called the hypotenuse. When you're using the Pythagorean theorem to find length of a segment, you're always finding C. This is always going to be C. Because if it was horizontal or vertical, you would have not made a triangle, you would have just counted it. Okay, so 4 and 9 are going to go in for A and B. And this becomes a much easier formula to solve. 9 squared plus 4 squared equals C squared. This is 81 plus 16 equals C squared. I add them and I get 97 equals C squared. And I have one more step to do to solve this. I need to do the opposite of squaring, which is square rooting. Okay, so that's where, this is actually where the distance formula is derived. So C squared, take the square root of that, I'm back to C, which is the solution I'm looking for, and square root of 97 is about 9 85/100ths. Okay, so that's another way that you can get the same answer that we got with the distance formula, but in my opinion it's a little bit more user-friendly. Again, you don't have to memorize it because I always let you use this, and you get to use this on the SOL. And it's a lot more straightforward to use because you're not dealing with negative numbers. These get tricky. The substitution gets tricky. I have had students that love this and want to use it every time, and that's fine with me. As long as you're getting right answers, I'm happy.